Module 4 shows how to perform a large displacement static analysis of a cantilevered beam having an elastic material. This is the fourth of 4 videos in Module 4. This video shows some of the tools available for analyzing the results. The solution has just finished and we are in the results section. The gold arrows represent the pressure loading acting on the top surface. As specified, we can see that these arrows are perpendicular to the surface. We can turn these arrows off so that we can better see the graphics information. Select Results Options, and then Loads and Constraints. We will set the scale factor used to displace the deformed shape to an absolute value so that we can see the true shape of the beam when it is loaded. We select Results Contours, Show Displaced, and Displaced Options. Note that there are 2 options for showing the displaced model. One is as the absolute value, the other is as a percentage of model size. We will select as an absolute value and set the scale factor 1 to obtain the true shape of the deformed beam. Note the significant increase in the displacement being shown. The default stress contour for a brick element is the von Mises stress. The von Mises stress can be compared directly to the yield stress of a ductile material to determine if yielding has occurred. The neutral axis of beams and bending can easily be seen in a von Mises stress contour plot. The thin blue line running down the center of the beam is the neutral axis. The compression on the bottom side of the beam can be seen by using the sigma ZZ tensor component. We select Tensor and the sigma ZZ component. Notice that we have a tension stress on the top fiber and a compression stress on the bottom fiber. This bottom and top stress values are approximately the same, which is consistent with beam theory. Each load increment is treated like a load case, and the load case control arrows can be used to select a specific load increment. The 0 load increment is the unloaded beam, and we can cycle through to see the amount of displacement or change in stress associated with each increment. This is increment 1 at 20% applied load, increment 2 at 40% applied load, increment 3 at 60% applied load, increment 4 at 80% applied load, and finally increment 5 at 100% applied load. This concludes this video.